Today's video is going to talk about Unit 6, Day 28 Vertex Form. What information can we gather using the vertex form of the quadratic equation? And I'm going to focus on reviewing the explore portion of the lesson with you. So we're going to go over how to actually expand this expression step by step, and then we'll also work through expanding the expression, the p of x function as well. Sorry, the r of x function. So let's go ahead and look at the first one. So h of x equals x plus 2 squared minus 4. So I'm going to then rewrite that as h of x equals, well, we know if we're taking x plus 2 and we're squaring it, we're really saying that we're doing x plus 2 times x plus 2 minus 4. Now, when we multiply x plus 2 times x plus 2, one great way to do that is to actually use this method called the box method. And this just kind of helps us organize our work. So I'm going to put that in there. And then I'm going to put we're just focusing on this part right now, this x plus 2 times x plus 2. I'm going to put x plus 2 and x plus 2. X times x is x to the second power. I'm just using that caret to represent x squared. X times 2 is 2x. X times 2 is 2x again, and 2 times 2 is 4. So now we can rewrite this as x to the second power plus 2x plus 2x plus 4. We can simplify by combining like terms 2x and 2x, and now we get x to the second power plus 4x plus 4. So that's where this kind of this part came from here. X squared plus 2x plus 2x plus 4 simplified now to x squared plus 4x plus 4. So I'm going to rewrite that over here. H of x. H of x equals x squared plus 4x plus 4. And I'm going to bring down that minus 4 now. And then we have the last step of combining these like terms, these constants. 4 minus 4 is 0. So now we have h of x equals x to the second power plus 4x, which matches our equation down here, our expression down here. Okay, so now you might want to pause your video and try this for the second example, set 2. How can you prove that r of x is equivalent to p of x by expanding it? Okay, so you might pause right now, and if you need some additional support, I'll help you get it set up right now. So we want to prove that r of x is equivalent, so I'm going to write r of x equals -1 times, and we're going to expand this part out. The quantity of x minus 3 all squared, well, we're just going to say it's x minus 3 times x minus 2. It's another way to write that, plus 4. You might pause here if you know what to do and continue working. If not, the next step, I'm going to draw my box because I'm going to use order of operations. I'm going to multiply these two terms first. These two binomials first, okay? Not terms, binomials. So here we go. I'm going to put x minus 3 on the top. And I'm going to do it here, x, and don't forget the -3 in this one. And then you can go ahead and multiply, find the areas of each box. You might pause here and do that part on your own. Or you might follow along. X times -3, -3x. -3 times x, -3x again, Negative 3 times negative 3, a negative times a negative gives me a positive, so I have 9. Next step is combine like terms. So I'm going to go down here. I'm just going to rewrite this. Minus 3x plus 9. But now I'm going to combine x to the second power. Negative 3x and negative 3x, they're both linear terms. They both have the same variable, so I'm just going to combine them. So now I'm going to bring this over here, but we have this negative 1 out front. So that's where this one gets a little trickier. So r of x equals, I'm going to keep the negative 1 and I'm going to put this in parentheses. Because that is the next step. With order of operations, I have to multiply this negative 1 as well by everything inside the parentheses. So r of x equals, well, we know negative 1 times x squared is just negative 1x squared, or negative x squared. We know negative 1 times negative 6 is positive 6x, and we know negative 1 times 9 is negative 9. We don't multiply the negative 1 by the 4 because the 4 isn't in the parentheses. And then the last step is we're going to combine those last like terms. Negative x to the second power plus 6x minus 5. And you should see that this expression matches our first expression, or this function matches our first function, the p of x function. So the goal is for you to see that these are all equivalent functions and these are all equivalent functions. They're just different ways to write the same quadratic function. And this form down here is the vertex form, which is a really important form because it tells us a key feature of that will be on the graph of that function. Okay, so in summary, quadratic functions can be written in multiple different ways, and these different ways show us different features on the quadratic graph.